Alright, so let's see what's in the box and then we'll go ahead and set it up.
Dropping stuff in there. I'm pretty sure that'll go into the pump. Bubble counter. Bubble counter. Bit. Instructions.
Now I'm going to go through the steps to install the calcium reactor. I'm going to go through it fairly quickly and just show some pictures of how I installed it. Place the primary chamber on its dedicated spot in the reactor base. Remove the CO2 interface chamber and its media from the box. The purpose of this media is to create irregular channels in the chamber to increase contact time with the CO2. You don't have to pack it tight in there. That will actually slow your flow and performance. Alright, make sure that you inspect the seals before you go ahead and place the interface chamber onto the main body. Alright, remove the CJ pump from the packaging and ensure the metal shaft is properly in place. Gently place the pump on its dedicated spot within the base. To further reduce the operation noise, large rubber dampeners are utilized. These dampeners, or rubber feet, have also dedicated machine spaces, circle spaces on the base where they sit on. Match the pump with its bearing plate fixed behind the pump head. There are 2 notches within the bearing plate that match identical cutouts on the motor block. Ensure the shaft is properly placed inside the rubber bushings on the bearing plate. Alright, now gently match the pump's output union to its matching counterpart welded to the primary chamber. Before you do this, make sure that the O-rings are present prior to tightening this connection, and then gently tighten that union. Then you can tighten everything up. Remove the bubble counter, flow meter, and its screws from the box. Fill the bubble counter with RO water. Place the bubble counter in its dedicated slot located behind the manifold. Place the flow meter against the acrylic holder. The acrylic holder has been machined in a countersink fashion to house the screw heads. Ensure the meter is placed on the right correct side of the holder. Use a flathead screwdriver. Tighten the titanium screws. Do not use excessive force, as this will damage the screw heads and the flow meter. Remove the secondary chamber from the box and place it on the hard flat surface. Mind the push connect fittings connected to the bottom of the chamber as well as other internal components. If placed on an angle or applied force against, this connection can break, rendering the secondary chamber unusable. Hold the bottom subchamber's body with one hand and the upper subchamber body with the other hand. Twist in opposite directions, and the bottom subchamber, the secondary chamber for carbonate media, will separate. If desired, this can be filled with additional calcium carbonate. Holding the titanium knob, remove the basket from the chamber. Using a flathead screwdriver, Remove the titanium screw from the top of the basket and remove the perforated plate lid from the basket. This basket can be utilized for additional media such as dolomite or other desired medias. Rinse your medias with RO water as well. Now place the lid back on and match the perforated lid's screw hole with that of the internal basket shaft. And using a screwdriver, gently screw the lid back on. Ensure that the O-ring underneath the top subchamber is properly in place. Now gently screw the top chamber back onto the bottom chamber. Place the basket back into the top subchamber. Make sure the basket is properly seated within the chamber. Hold the top subchamber acrylic body and screw the lid closed with the other hand. Ensure that the O-ring on the top of the body is seated properly. Inspect the threading both on the lid and its counterpart on the body to be free of debris and any other medias. Now the secondary chamber can be placed in its dedicated slot within the reactor's base. A dedicated small rectangle slot has been milled into the reactor's base to house the push connect fitting located at the base of the secondary chamber. Alright, assembly is almost complete. We just need to make sure that everything is tight and make sure that there are no leaks. So we're going to check everything that we've done so far, make sure that there's no leaks. Now go ahead and remove the needle valve from the box. Insert the valve into its dedicated slot on the primary chamber's manifold. Now there are 3 sets of LLPDE tubing provided with the unit. Different colors can be used to code incoming internal connections and or effluent tubes. Further to that, small holes have been milled into the bubble counters holders that can help you achieve a neat setup. You can simply run any tube through any of the 5 machine holes. Use a sharp knife to cut the tubing in desired lengths. It is imperative to cut the tubes with a clean straight end. Angle cuts will possibly cause leaks, so make sure that you cut it properly. So this first connection that you see is for unused CO2. It connects to what's labeled J, the quick connect labeled J. It's the first one that you'll see on the lid, and it'll connect to the first quick connect on your manifold, which they label K. Basically it'll take the unused CO2, place it right back in line to get sucked down into the recirculation pump. The second connection that you see is for your effluent. It leaves the primary chamber and it's going to go down to your secondary chamber. Connect the top of the needle valve to the bottom of your flow meter. Connect the effluent leaving out of your secondary chamber to the bottom of the needle valve. Now connect the CO2 output from the bubble counter to the CO2 input on the manifold. Connect your effluent line to the flow meter, and you can pretty much place that where you like, but make sure that it's above the water surface. If you place it under the water surface, you can cause siphoning effects and things like that, or it'll clog up as different debris gets in it or tries to get out of it. Now I set up mine a little differently, but you can see my CO2 going into the reactor. I have a carbon doser, which gives me a little bit more precision. Then I have a continuous duty pump. That also gives me a little bit more control. That way I don't have to guess how much I'm dosing into the tank. And then I have my pH probe at the top, and I can monitor my pH with my Neptune controller. And that's it. Thanks for watching.